Hello everyone, this is Jeon Poljong. Today I will explain network functions, virtualization, NFV. The contents are as follows. Firstly, we will study network functions, virtualization, NFV. Next, ETSI, European Telecommunications Standards Institute standardization activity for NFV standards. Thirdly, open source projects for NFV such as OpenStack, OpenMano, and Open NFV. And then I will conclude today's class. The first topic is network functions, virtualization, NFV. Basically, NFV is a specific functionality module as a networking or security service for internet service provider. It is called the ISP. The examples include DPI, deep packet inspection, firewall, broadband remote access server, CG, NAT, carrier grade network address translator, and session border controller. Also, the mobile network case, GGSN, gateway, GPRS support node, and SGSN, solving GPRS support node, and provider edge router. So these are the figures: DPI plus GGSN or SGSN. This is provider edge router, firewall, CG, NAT, session border controller. Let's compare legacy approach and the virtualization approach. So left-hand side, traditional network model. It is called appliance approach. Right-hand side, virtualized network model. It is called virtual appliance approach. Basically, appliance case, we have a hardware box and the software is embedded, a kind of middle box approach. Network functions are based on specific hardware and software together, one physical load per role. On the other hand, virtual appliance approach case, we have a bunch of standard high volume servers, bare metal servers in cloud data center, and then we make virtual network function, and then we allow network service like DPI plus firewall, etc. So virtual appliance can run on top of this virtualized server. Network functions are software-based over well-known hardware. Multiple loads over the same hardware are allowed. Let's take a look the introduction to network functions virtualization. Motivation of NFV is to allow network service providers such as KT Korea Telecom and AT&T in the United States to construct their own network services in virtual environment, and also to allow the virtual machines for those network services to be scaled up and down according to customers' demand, on-demand service. The principle of NFV is that NFV orchestrator governs network functions for network services running on top of a virtual machine or container in virtual environment in a centralized way. Secondly, network functions can dynamically be created or deleted according to the commands from NFV orchestrator. This is called life cycle management of network functions. Okay, the background and the concept of NFV NFV was born to meet service provider like Google, Amazon, and something like that. So to roll CAPEX, which means capital expenditures, and OPEX, which means operational or operating expenditures, by reducing and eliminating proprietary hardware. To consolidate the multiple network functions onto industry standard platforms. So this figure shows the combination of open innovation, software-defined networking (SDN), and network functions virtualization. So open innovation creates a competitive supply of innovative applications by third parties. Open source projects are engaged. SDN case, it creates network abstractions to enable faster innovation. Thirdly, NFV reduces CAPEX, OPEX, service, and power consumption. NFV architecture. This figure shows NFV architecture. This figure consists of 3 layers. The first layer is NFVI, NFV infrastructure layer. Second layer is VNF instances layer. And third one is network service layer. So let's take a look at each of them. So basically, NFVI is manage hardware resources such as compute node, storage node, network node. Those hardware resources are virtualized by virtualization layers such as hypervisor into compute virtualization node and storage virtualization node and network virtualization node. Okay, so those are kind of Lego blocks to make network function like virtual network function, VNF. Okay, so VNF is mapped with network services. You can see one network service make multiple VNF. Okay, so they are interconnected using virtual link, okay, or logical link, okay. So such as some certain service, security service, including firewall, replica, distributed denial of service, DDoS attack mitigation case. One bundle network service can constructed using multiple VNFs, okay. So the entry point in the packet, the ingress point, and this is end point is packet egress point. So virtual network function VNF case. VNF is a software that implements the specific network services or functions that can be deployed and operated within on NFV infrastructures. Such as virtual switches, firewall, DPI, transcoder, gateways, etc. A VNF can consist of a single component, or you can see single component is construct one VNF, or multiple components, VNF C1, 2, 3 can construct one VNF, okay? And then VNFCs, these are interconnected using internal links linked to each other in the form of a graph using service function chaining. This shows a specific construction of network service. So the previous one case, one VNF case, multiple modules of VNF components all interconnected. In a similar way, network service like a series of security services. VNF1 is a firewall service. VNF2 is web filtering or web filter, and vendor 3 is DDoS attack mitigator. Okay, so those are can be interconnected. So certain cases just the VNF1, VNF3 are just connected. Firewall service, DDoS attack mitigation service. Another service case, firewall service, web filter service, and DDoS attack mitigation service together. So we make two passes. So this passes is called the service function SFC pass. Okay. So SFC specified by ITF standard RFC 7665 service function chaining SFC architecture. So you can refer to this document to see service function chaining. Okay, let's move on. The second topic is ETSI, standardization activity for NFV standards. Okay, so you can click this link and then you can see ETSI standardization document, NFV architectural framework. So left-hand side, it shows NFV reference architectural framework. So it consists of two parts. This is NFV infrastructure, NFV framework, and then right-hand side, it is a kind of controller or brain of NFV. It is called a MENO. MENO stands for management and orchestration. Okay. So the upper one, OSSI/BS means operating support system and the business support system used by dashboard used by network operator. And EMS is element management system. It is managing its own the system product. So for example, EMS1 can make the firewall case, firewall image run on top of VNF1. So EMS1 is in charge of this VNF1 management. VNF2 in charge of VNF2. Similarly, EMSN in charge of VNFN, right? So those are implemented on top of VNF, okay? And then this layer is the NFV infrastructure layer. So basically, based on virtualization layer, hypervisor making virtualized compute storage network node based on this hardware compute storage network resources. And right side, the MENO is orchestrator managing network services. And VNF manage VNF stop, and Beam manage NFVI this infrastructure. So MENO management and orchestration, this module consists of orchestrator, VNF manager, VNFM, virtualized infrastructure manager, Beam. Okay. So let's look at one by one. So typically MENO is important component because this is brain for NFV framework. So the first component, the MENO orchestrator, management for lifecycle and component of a network service, description for NFVs, instance of network service, VNF manager, instance of VNFs, forwarding graph are handled. And also management for resources through Beam is performed. The second component in MENO, VNF manager, manage a life cycle of VNF instance, such as creation, verification, software change, scaling up or down, restoration, and deletion of VNF instance. The last component, MENO, Beam, virtualized infrastructure manager. The management for NFV infrastructure, NFVI, orchestration of NFVI resource, management for inventory of NFVI resource, management for capability of NFVI. Also, it manages resources of computing, network, and storage resources, and also the manage software image for virtualized the resources. NFV infrastructure consists of hardware, this one hardware, software, okay, to create the VNF, okay. To provide VNFs with infrastructure resource environment, infrastructure has computing node, storage node, network node, right? This one, and also using a virtualization layer, for example, hypervisor, virtualize this hardware resource into virtual resources. Okay, so the virtualization layer, such as a hypervisor, virtualizes the infrastructure nodes into virtualized nodes. The third topic is an open source project for NFV. We have 3 open source projects for NFV. The first one is OpenStack. Second one is OSM, open source manual. Third one is OP NFV, open platform for NFV, OP NFV. Okay. So OpenStack is a project that provides a cloud operating system to virtual environment for virtual network functions. You can visit this link. And OSM, it is a project that provides a practical implementation the reference architecture for Mano in ETSI NFV. You can visit this OSM website. Lastly, OP NFV, open platform for NFV, facilitates the rapid development and testing of NFV components across various open source ecosystems. You can visit this OP NFV website. We can take a look each of them one by one. So OpenStack is a cloud operating system. In order to control a large pools of compute, storage, and network resources in a data center, to provide the administrator with a dashboard, okay, like this dashboard, okay, web-based Horizon Web UI dashboard for control and monitor, and to provide users with a web-based interface for resource provisioning. Okay, so OpenStack, where matter the machines are the compute, and this is the storage and the network, right? And then virtual machine or container also can be used. So the virtual machine VNF or container cloud native system are merged nowadays. So the container typical one is Kubernetes. Okay. This is OpenStack project. Okay. So a lot of projects are undergoing for OpenStack. So OpenStack case, you can see compute project and the storage project and networking project and the hardware lifecycle management project. Also web-based management, Horizon, EC2 API for Amazon, okay, service, cloud service, and the workload provisioning, application lifecycle management orchestration, okay. So client toolkit, OpenStack client, Python SDK, user client side, integration enabler, container services, courier, and NFV Tacker is used. And then operation tool case, the monitoring service, resource optimization, billing, and the business logic, testing, benchmark case, those projects are used. And the lifecycle management case, deployment and lifecycle tools case, we have several tools, okay, and also packaging recipes for Yeah, OpenStack. Okay, you can visit this OpenStack to see those kinds of ongoing projects. The second open source project is open source manual OSM. OSM is an open source manual for ETSI NFV framework. So OSM document you can visit. Okay, here, and open source manual. Basically, it makes the manual system. Okay, and then it, so using OpenStack northbound interface, and a governs compute network storage services. Okay, and also here the upper layer OSM client, OSM GUI, and then we are providing the OSSI, PSSI. Okay, operator support system and business support system can be done. Okay, so and then in the middle we managing VNF and lifecycle management manager and resource orchestration and monitoring and policy management are provided. Typically OSM handles the VNF managers. Okay, it implement the VNF managers as integrated component of OSM. This split its functionality, this one, into multiple sub-modules for abstraction. So you can see SO layer and RO layer monitoring module and the VCA module. Let's take a look one by one. The resource orchestration RO handles the cloud and the physical resources, and the VNF configuration agent, the VCA, handles the interaction with NFs and the applications. And the monitoring component, MON1, monitors the procedures in the system in manual, and service orchestration SO is a layer to provide end-to-end coherency. Okay, so you can see each module has an interface. Okay, interacting with the outside entities. Okay, so for example, OSM monitoring case, they connected VNF or LM manager or VIM SDN controller for SDN networks. Okay, you click this one, you can get more information about this part. The last open source project is OP NFV. So OP NFV provides an ecosystem for developing and testing a reference NFV platform for enterprise and service provider networks. Its goal basically to accelerate the time to market for NFV solution. Basically, the OP NFV is a kind of development, some platform, integrate code and the test, and then new feature can be plugged in. So left hand side is NFV framework, right? Infrastructure. This is okay. Storage, compute, the network, virtualize. This is a NFVI, and then a personal network function layer, and then here upper layer is the manual management and orchestration. So those NFV, NFVI, VNF, and OP NFV manual case integrated tested new features can plug in. Okay. So this is a development testing framework for NFV. In conclusion, in this class we learned the following: network function virtualization NFV, ETSI standardization activity for NFV standards, and also we looked at open source projects for NFV, OpenStack, OSM, and OP NFV. NFV is a cornerstone for network software realization along with the SDN, software-defined networking. And then virtual network function VNF for a network service is being replaced with a container that has a light architecture, like Kubernetes. Okay. In this talk, we will set up an SDN network and an NFV based cloud. Thank you for your attention.